Hey guys, welcome back everyone. So yesterday we have seen that BGP route reflector. So basically what happened, we had an issue with the full mesh, right? In the full mesh, what happened? Every router is going to make a neighbor issue with every router. So in that case, what happened? We're just going to increase the TCP session, right? So to avoid that problem, what we have introduced, the concept of BGP route reflector. And what BGP route reflector is going to do, it is just going to reduce the TCP session, or also it is going to disable the behavior of split Trojan loop. So we can see that the route reflection is the alternative method of the full mesh, right? That is introduced in the comes in the RFC 1960. Okay, and what route reflector is going to do over there? So whenever the server, so I'm just recapping. So whenever the server, for example, is my router number 1, router number 2, and router number 3. In this case, what happened? For example, I'm going to make this router as a server, right? And this guy has a client, and this guy has a client, and this guy has a 1.0.0/8 information, right? So when R1 will serve this information to the R2, what R2 will do in this case, R2 will install this information in the BGP table. At the same time, in the routing table, this star is just going to represent as a valid, and greater than is going to represent a best, right? So if the route is valid and best, I'm going to install this route in the routing table as well as. And after that, what happened? I'm going to advertise this information to the R3, because this is my server. And what server is going to do? It's just going to make a reflection. Reflection of what? Reflection of route, right? So in the route reflector, we have seen that we have a three types of router. Yesterday we have seen that we have three types of router. One, we have a client peer, one we have a server, and one we have a non-client peer. Non-client peer in the same, like you're not going to enable the route reflector on that particular client. Like in this example, so this is how the route reflection is working, right? Yesterday we have seen this example as well as. So when the sunlight is coming to the this surface, what this surface will do, they will just reflect the information. Same thing the route reflector is going to do. So when this router is going to send this information to the server, what server is going to do, they will just reflect this information to the another client, right? So basically what happened, take example in this case, this is my route reflector server, right? And in this route reflector server, what happened, this my router 1 is a client, router number 3 is also my client, right? And router number 4 is my non-client. Non-client means the sense of what? This behave like a server, right? This guy's a server, this guy's a client, this guy's a client, and this is my non-client. Non-client means I'm not going to define the name. For example, on a router number 2, what configuration I'm going to do? On a router number 2, I see that, let me do one thing. Let's open the notepad. I said router BGP number 1, that's my EH number, I see the neighbor. So I already have a neighborship. I'm just going to define the router configuration. I see that this guy, you are my client, you are my client, right? But what about this guy? I'm not going to define anything for you, right? I'm just saying that router BGP number 1 on a router number 2, right? So if I'm going to define on router number 2, so this router number 2 is behave like what? This guy is going to behave like a server. There's no specific command to make a router as a server. You need to assume that, okay, this router has to become the server, because R2 is behave like a centralized. It's a central location, right? So you need to make this guy as a server. So in this case, what happened? Once I'm going to define the neighbor 12.1, you are my client, and neighbor 23.3, you are my client. So itself, R2 is behave like a server, and this guy is my client, and this guy is my client. Did I define any commands for this person? No. So if I'm not going to define, what happened? You behave like a non-client. This is the rules of route reflector. So what rules is saying that? The rule is saying that a route received, listen to me carefully, a route received from a route reflector client are reflected to both client and non-client peer. For example, when this R1, so right now this guy is a server. Let's do one thing. I'll make this guy, this is my client. Okay. Client, this is my server, and this is my client, and this is my non-client. So what this guy is in the first line is saying that Route received from the route reflector client. So when R1, this is my client, will send this information to the R2. Which information? 100.0.0/8. What R2 will do in this case? It will reflect that information to the client and non-client as well as. So they will share this information to the R3 and R4 as well as client and non-client. This is the first rules. Second rule is saying that if route reflector receive an array, or we can say the prefix from non-client, that's a non-client, right? So when R4 4.0.0.0.0 will advertise this information to the server, right? The route reflector advertise the array to RR client. It only advertises this information to this guy or this guy. It does not advertise the NRI to the non-route reflector client. So in this case, what happened? For example, R4 is non-client, so R5 is also behave like a non-client, right? It's not going to say this information to this person. I'll either do one thing. I'll make it not this one. Let's remove the BGP from this case, right? I'm not interested in this one. Let's do one thing. I'm going to make this guy as a non-client right now. Non-client. So in this case, what happened when non-client will send this information to the R2, right? R2 will receive this information. They will put this information in the BGP table, or they can advertise this information to the client only, not to the this guy. This R3 is behave like a non-client right now. And the third rule we have a, if RR receive the route from the eBGP peer, right? If the route reflector receive a route from the eBGP peer, it advertise the route reflector client to the non-client as well as. So when R5 will send the own information to the server 5.0.0.0.0, in this case, what happened? R2 will share this information to the client, and non-client as well. This is the rules that you have to follow whenever you're going to implement the route reflector in the IBGP. So if you just have a look, guys, over there, what I can do, I'll just go to yesterday topology. I have, I think so. 1 minute. Make it. I have a save topology. BGP route reflector rules somewhere. It's written. Yep. Same topology yesterday we have, right? So this is my three rules are there. So the rule number 1, 2, and 3. So now try to understand this topology. All good. So let's do one. Let's start this guy. And what I can do right now, I'm just taking console of this R1, R2, and R3 every router. So remove this guy and take a console. So I'll show you the first pre-configuration, right? And after that, we'll go through the rules. All good. So if you just go to the router number 1, that's router number 1, and if you verify the IP configuration first of all, it's very good to first verify the configuration, and then after verifying the configuration, then you do whatever the configuration is required, right? Always make a pre-verification first of all. I have a configuration IP addressing right stored on section BGP. We all have a BGP as well as. No, don't have a BGP. Let's do one thing. Let's run the BGP. So router BGP number 1, BGP router ID will be neighborship. I'm going to form with the 2LR2. That is this guy. R1 is going to form the neighborship with the 2LR2, and that belong to the same AS number. IBGP, right? Let's go back to the router number 2. That's behave like a server. Show IP interface brief. All they have a good IP addressing, right? Yep, almost. Yep, everything is good. I need to create a one loop back that's behave like a router ID of BGP so that we can easily identify, right? I need to say router BGP number 1, BGP router ID will be 2.2.2.2.2. Neighborship I'm going to form with the 2.1. Remote AH will be 1. Neighborship I'm going to form with the 23.3. That is this guy. They belong to the same AH number 1. And I'm going to form the neighborship with the 24.4. Right, that is this guy, right? Same AH number 1. And I'm going to form the neighborship with the 25.5. That is this guy. That's the eBGP. All good, right? What is the next thing? Let's Go on router number 3 and let's verify the configuration on our router number 3 as well as that is this guy. Show IP interface brief. All we have IP addressing configured over there, right? Showdown section BGP, so IP protocol summary. I don't have BGP, so let's configure the BGP on this guy. Not 101.3.3.3. Neighborship I'm going to form with the 23.2. Remote age will be 1. Everything is good. Next thing we have, okay, just wait for some time. Let me form the neighborship, then we'll go for the next order. So I've already defined the command on this line 23.3. Okay, it has to form the neighborship. Wait for some time because BGP is a slow routing protocol. Yep, bingo. So now let's go for the router number 4. Show IP interface brief. All good. Do show IP protocol. So IP protocol summary. So my BGP is not enabled. Let's enable the BGP on this guy, BGP1. I need to define the router ID manually. I know if I don't define the manually, it will go for the highest loop back. But always recommendation to configure router ID manually. Make a habit of this thing. 1 and perfect, right? And let's go now router number 5. That is the eBGP connection we have. So IP protocol summary. All no neighborship is there. So let's configure the BGP5. And I'm going to form the neighborship with this person, 25.2. That is the remote edge number 1. Everything is good now. So R2 is going to make a 3 neighborship, not 3, 4. 1 for this guy, 1 for this guy, 1 for this guy, and 1 for this guy. So total 4 neighborship on R2 we'll have. So just wait for some time. It's a little bit slow routing protocol. Finger crossed. I hope I can get this. So it's good, right? On R5, I did the configuration 25.2, and that's when I was remote sure everything's good, right? My interface is up. Oh, the mistake is there on the 0/0 interface. I've configured the 25.5, but the diagram is 0/1, right? So mistake is happening. It's 0/1. So let's do one thing. Default, I'll make this interface 0/0, right? And now I'm going to say interface 0/1. IP address will be 25.5, and that has to be submit mask /24 and also down. Let's say this configuration. Now, hope you will get the neighborship. Come on, yep. So now what happened, guys? Once I have a neighborship, if you see show IP BGP summary, I have a 4 neighborship and so TCP brief. I have a 4 TCP session over there. All good. Now, what is the next thing we need to do on a router number 2? I need to configure router BGP number 1 and set a neighbor 12.1 route reflector client. I'm going to make this guy the client. I'm going to make this guy as a client as well as 23.3. So R2 has defined, hey, you are my client and you are my client. I'm not going to define for you any person because you are my non-client. So my first rule, right? Okay, before I'm going to move to the rule, as we know that yesterday we have discussed this thing, whenever, okay, come on, whenever BGP router whenever BGP router receive any update, whenever the BGP router receive any update, first next hop reachability, right? If the next hop is reachable, if the next hop is reachable, then I will mark that route as a best and valid. And if the route is best and valid, if the route is best and valid, then I will install that route in routing table. But if the route is just a valid, not best, then that route will be not installed. Because routing table always maintain the best path. Because routing table always maintain best path information. So right now, what I can do, guys, I'm just going to configure the AGRP over there, right? In this link, I'm going to advertise in the AGRP so that we have a next hop reachability, right? Because as we know that also, IBGP does not change the next hop, right? This is the most important point. IBGP does not change next hop, whereas EBGP does change next hop. That's a default behavior we have seen yesterday, right? So what I can do right now, I'm just going to enable the HGRP. Okay, so we have our reachability router HRP number one network. I'm going to just advertise my WAN connection, right? 12.0 to just have a all good. Just have a reachability. That's it. Nothing else. And R4 all good. Let's make it R5 as well as all done. So now let's go back to the router number one. The first rule is saying that route receive from the route reflector client, right? So this is my client. So when a client will say this information to the R2, which information 1.0.0.0 reflected to the both client and non-client. So it will say this information of this person and this person as well, right? So let's do one thing. Let's go to router number one and advertise this route in the BGP. Router BGP number one, always we are going to advertise the customer route into the BGP. Always we are advertising customer route into the BGP. Now have a look. R1 will say this update to the R2 and R2 will say this update to the R3 and R4 as well. Got the information right? And this I is just going to represent that it's a IBGP, right? So route server will receive this information. What are the client information? The R3 is a client. We have information, right? Next hop is reachable. So that's why what happened. I will put this put this route as a best and valid because the next hop is reachable from me, right? I can ping this guy. And on R4, do show IP BGP as well as that's my non-client. This is my non-client, right? So I can receive the information as well as R5 if you see, do show IP BGP. All good. So here I is not there, right? Because this route is coming from eBGP. And for the eBGP, the route AD will be 20. For eBGP, the AD will be 20. For IBGP, the AD will be 200. So hope this rule number one is clear to all of you guys, right? Rule number two, if RR receive a NRI, that's a prefix, right? From non-client, the RR advertise the NRI to the RR client only. It does not advertise to the non-client. So what I can do, I'm just going to make R3 as a non-client right now. I'm going to make R3 as a non-client. How do I make this guy? I just need to go on the router. I just need to go on the router number two. And I said, hey, do one thing, no neighbor client. I'm just going to disable now. So right now, in this case, what happened? R4 and R3 is behave like a non-client. So the rule number second is saying that if router number four, that's a non-client, will advertise the information to the server, it only advertise that information to the client. Only client. So if you have a look over there, R4, I said a network Okay, let's me go to the BGP mode. Network folder 0.0.0.0 and have a look. R4 will save this information to the R2. R2 will have this information in the BGP table, right? Getting from the I, that's IBGP, and for the IBGP, the AD value 200. Now, if you go back to the router number 1, R2 will save this information to the client only. So if you see, do show IPBGP, we have a 4.0. IBGP does not stay in the next hop, right? So still the next hop is 24.4, right? On R1. If you go back to the router number 3, do we have this information? No, I don't have this information because R2 is only going to share this information to the client. It will never share this information to the non-client. So that's why we don't have this information on the non-client. This is my eBGP peer, guys. It's not belonging to the route reflector. That's why I'm advertising this information to the other person. This is not a part of the IBGP, or we can say that this is not a part of the route reflector. It's not a part of the ACE number 1. It's a part of the eBGP, right? So it can share this information to this person, but not to this guy. The third thing we have, let's do one thing now. Let's come back to the router number 2, and I'm going to make this guy 23.3. Hey, you are my client now. Previously, I removed this command. Now, if you check R3, previously R3 was not able to receive the route, this 4.0. Now they will. The rule number 3 is saying that if the route reflector receive a route from eBGP peer, right, it advertise the route to the RR client or non-client as well as. So if R5 will say this info to R2 5.0, server will reflect this info on this person, and this person as well as. So if you just go back to the router number 5, router BGP number 1, okay, 5 network 5.0.0.0.0, R5 will share this information to the R2, and R2 will reflect this information to the all client or non-client as well as. So go back to the router number 1 first of all, and verify do show router number 2, do show IPBGP. Server is receiving this information, right? So we don't have an I over there because I'm receiving this information from eBGP. So for the eBGP, what will be the AD for this person? 20. For the IBGP, 200. So what R2 will do? R2 will reflect this information to the client, right? Client, non-client as well as. This is the rules of the IBGP, guys. Hope this thing is clear to all of you guys. If you have any questions, you can ask me. From my side, this rules of is done. The route reflector. Okay. So the rules are clear of the route reflector, and the basic configuration is also clear of the route reflector, right? The next thing we have loop prevention in the route reflector. So basically, what happened actually, I'll tell you. Let me open the print. See, right now these are my routers, right? Router number 1, router number 2, router number 3, router number 4, router number 5. So all this router has a connectivity like this, right? So all this router is belong to the which edge number? I can see that this router is belong to the edge number 1. This router is belong to the edge number. So it means that we are going to run the IBGP over there. We can see the internal BGP. We can see the internal BGP. Now try to understand this logical, this domain that have this edge number is what? This edge number is a group of router, right? Edge number is a group of router. And this group of router is designed with the logical domain, right? So it's a logical domain I'm going to use over there. So it's a group of router. This group of router is present in the logical domain, and that logical domain is identified by the edge number. Okay, all good. And this edge number could be a 16-bit as well as and 32-bit. Now, here we have done, right? Now, what happened in IBGP? We have a split horizon rule, right? In IBGP, we have a split horizon rule, and there is no command to disable the split horizon rule. To disable the split horizon rule in IBGP, we have to use the full mesh, we have to use the route reflector, and you have to use the confrontation. Three rules we have, three mechanism we have, and based on this three mechanism, we can disable the rule of split horizon rule. Sorry, we can disable the split horizon rule, but there's no command. Try to understand. I cannot use the full mesh because I cannot say that I cannot use the full mesh because the full mesh requires a lots of configuration. It's not a scalable way, right? If you have multiple router, if you have 20 plus router, you cannot use the full mesh over there because it requires huge amount of configuration, right? And it on a single router you need to maintain the lots of TCP session, and each TCP session is going to have a separate TCP block, and each TCP block has a separate database table, right? So they will maintain the huge amount of memory. They need a huge amount of memory to maintain all this information. The router needs a huge amount of memory to maintain this all information. So the full mesh is not a good way, right? So I can use the router filter. Now try to understand, if I'm going to create a router filter, if I'm going to create a router filter, at the same time, what happened if I'm going to deploy the router filter over there? Same time, what happened? This guy is also going to make a another logical domain. This guy also going to make a another logical domain. Try to understand this one is another logical domain, this one is another logical domain, this yellow is another logical domain that is going to represent the h number one, that's IBGP, and this one, this color is going to represent another logical domain, that's for the router filter. Or in this case, what happened, I can make any router of the server, right? So I can make this guy as a server. So okay, sorry, so this is my server, right? So this will be client, this will be client, this will be client, and this will be client. So in this logical domain of the router vector, we also have a loop. We'll also have a loop. How? For example, if our this guy, right, this router number one, and this is the router number two, and this is router number three, and this is the router number four, and this is router number five. Take example, router number one has an information 1.0.0.0.0 slash it. All this router represent the same domain, right? So R1 will say this information to R5, that's the server over there. And what server is going to do? Server will reflect this information to this person, and this person. I'm reflecting the information to every person, right? In this case, what happened? Does this router has any mechanism to see is there loop is happening? Does this router has any mechanism to see is there any loop is happening? And does this router has any mechanism to see any loop is happening? No. So under this domain, what happened to prevent the loop? We are going to use the two extra information. The first information we have a originator ID, and second information we have a cluster ID. First of all, I'll tell you, according to your syllabus, these two things are not there in your syllabus, right? According to your syllabus. According to your syllabus, I'm done with the route. I'm just going to teach you the originator ID. The cluster ID, I'm just going to give you the overview how the cluster ID is working. I'm just going to teach you how the loop prevention is happening within the same cluster. So originator ID is what? I'll do one thing. Okay. How can I show you like this? I said two things is happening. One is the originator ID, and one is the cluster. The cluster ID is also known as a cluster list. So basically what happened, take example, this is my router number one, router number two, router number three, router number four, router number 5, router number 6. Try to understand this topology. It's a very interesting topology, right? And if you have a time, if you don't do that, you can do that this topology as well. It's very good topology. Try to understand all this router are positioned in the same IS number 1. It means that router number 1, 2, 3, 4, 5, 6, 7, 8, 9. They all run with the which mode? IBGP. But but the thing is that I'm going to make a one logical domain for this person right now. I'm going to make a one logical domain for this person right now. I'm going to make a one logical domain for this person right now. Listen to me. All this router belong to the same H number. They have a IBGP session. But under this IBGP, I'm going to make this guy as a server. This is the client. This is the client. I'm going to make this guy a server and this client, this client. I'm going to make this guy a server, this client, a client. So how many server we have? We have a multiple server. So within the, this is my one cluster, right? This is my one cluster. We can see that. One cluster means one domain we have. This is my another cluster, one cluster. And all this cluster is different to with one, right? So this cluster is different, this cluster is different. And we have another cluster one. So to identify this cluster domain, what happened? We have a cluster ID. To identify the cluster domain, we have a cluster ID, and that cluster ID will be a router ID of server. For example, 2.2.2.2.2. The cluster ID of this guy is a 4.4.4.4, the router ID of R4. You can manipulate this thing as well as, don't worry. And the cluster ID of this domain will be 7.7.7.7. So try to understand within this cluster, we are going to use the originator ID to prevent the loop. We are going to use the originator ID to prevent the loop. Originator ID in the sense of what? For example, router ID of R1 is 1.1.1.1.1, right? And router ID of R3 is 3.3.3.3.3. Try to understand if router 1 has a 1.0.0 information over there, what R1 will do in this case? R1 will share this information to whom? R2. Listen to me. R1 will share this information to R2, 1.0.0. In this case, what happened? This router is going to put the own router ID over there. The originator ID is 1.1.1.1. When R2 will share this information to the R3, do you know what happened in this case? R2 will send this info 1.0.0.0.0. What is the original ID? 1.1.1.1. So when R3 will receive this information, what R3 is saying that, hey, my router ID is 3.3.3. Someone is saying the update to me that has a router ID 1.1.1. This router ID is different, right? This router ID is different. I can accept this update. I can accept this update. But if this person has a also have a same router ID 1.1.1, like this guy, do you know what happened? When R2 will send this update to the R3, R3 will just discard this update because they have a same router ID. So within the cluster, how we are preventing the loop based on the originator ID within the cluster. But between the cluster, what happened? Try to understand when R2 will send this update to whom? R4. Which update I'm talking? This is 1.0.0. In this case, what happened? It is still putting the originator ID is what? 1.1.1.1. But in this case, what happened? They will put the cluster ID, this 2.2.2, the router ID of server. R4 will receive this information. R4 will say this info R5. R4 will say this info R6. When R4 will say this info R7, when R4 will say this info R7, so in the R7, how they will receive the update? They will receive the update like this: 1.0.0.0.0.0. Originator ID is what? 1.1.1.1.1. Cluster list will be what? It seem like a AS path information. Same like a AS path information. Router 4 is going to prepend the cluster. Router 4 is going to prepend the cluster list. He's saying that, okay, the update will be happen like this. R2 is sending this update, right? 1.0 information with the original ID 101, cluster ID 2.2.2. That's a R2 router ID. But when R4 is the server will send this information to the R5 and R6. But when server is going to send this information to the another server, in this case, what happened? Is going to say, okay, cluster will be Prepend, I'm going to prepend the 4.4.4.4.4 and 2.2.2.2. Cluster list like a ACE path information. When R7 will say this in front of the R8, R9. So how they will send this information? They will say this information with the cluster ID what? Cluster ID 2.2.2.2.2.2, then 4.4.4.4.4, and then it is going to prepend the only cluster ID over there, right? For which of this update is for what? 1 or 0 or 0 or 0. R8 will accept this update, right? But try to understand one thing. If R8 has a connectivity with the R2, then don't you think you will have a loop over there? So in this case, what happened? When R2 will share this information, same update 1 or 0 to R2. In this case, what happened? They will send the update like this 1 or 0 or 0 or 0 or 0. The cluster ID is what? Cluster ID will be 2.2.2. Sorry, not 2.2. It will have 8.8.8 first of all, then 4.4.4.4 and 2.2.2.2. So when R2 will receive this update 1 or 0 or 0, he's saying that hey, what's the cluster ID? 8, okay, fine. 4, okay, fine. 2, that's my own cluster ID. I'm just going to discard this update packet. Just going to discard this update packet. So originator ID is what? It's going to prevent the loop within the cluster. Or cluster ID is what? It's going to prevent the loop between the cluster. And the size of both this person is a 32-bit. Size of this person is totally 32-bit. So if you just have a look, guys, over there, what I can show you, this diagram, right? Sorry, stop closing this diagram. And this cluster ID and at this cluster ID, this cluster ID and originator ID, right? It's a path attributes of the BGP. As I told you that whenever the BGP router advertise the information, it puts some extra information in the route, right? Whenever the BGP router advertise some information, it puts some extra information to the particular route, and that extra information is known as the BGP attributes. So this cluster ID and originator ID attributes will be implemented, or we can say that this cluster ID and originator ID attributes will be added whenever you're going to implement the route reflector. It only present with the route reflector concept. By default, it's not there. If you just have a look, do one thing. So let's verify the what are the pre-configuration we have. If you see router number 1, and the originator ID and cluster ID will be represented in the IPv4 format, like a router ID form. So IP interface brief. I good to go. I have a right IP addressing over there. So IP protocol summary. The BGP is there. Perfect, right? So run section BGP. I'm going to run the EHRP so that we can have a reachability of the next hop, right? That's very, very important. So IP interface brief, all good. So IP protocol summary. BGP is not there. So let's do one thing. Let's enable the EHRP first of all. And I'm going to enable the BGP as well as router BGP number 1. Neighbor, I'm going to form the neighbor the 12.1 that has a remote issue will be Shimation, right? That is this guy. On a R2, I'm going to form the neighborship with a 3 as well as, and I'm going to form the neighborship with a 24.4 as well as. Same mission. All good. R3 shows IP interface brief. R3 has a good to go on a 23.3 and they have a one loop back 3. Show IP protocol summary. BGP is there. So BGP is also configured over there, right? All they have good configuration, right? Router HRP number 1 network 23.0. Just make a reachability. That's it, nothing else. So next hop reachability is most important in the BGP, right? Because by default, IBGP does not change the next hop. We need to provide the reachability. Now router number 4. Come on. All good. So they don't have any loop back right now. Forget it, no issue. So I will do a summary. BGP 1 Neighborship, I'm going to form with the 24.2. Remote edge will be 1, and I'm going to enable the router edge at 1 of the 2. Try to understand router BGP number 1, BGP router ID 4.4.4. I'm going to define the router ID 4.4, this guy. So this guy has a route ID. We write now 4.4.4.4.4, right? This guy's a route ID right now 3.3.3.3, and this guy's a route ID right now. It's a 10101. Everything is cool, right? What I can do, if you just have a look the normal update message, if you just going to capture this link right now, and this link as well as, okay, and let's do one thing. I'm going to advertise a route from the R1, right? Network. So R1 will send the update packet to the R2, right? Not this one. I'm interested in the BGP update. Yeah, okay. I by my mistake, right? I've advertised in the HRP. R1 will send the update packet to the R2, right? So this update message, can you see that in the array information we have? And if you see the path attributes, the ACE path is empty, right? ACE path is empty. And do we have any like this information, originator ID and cluster ID information? No, we don't have, because these two attributes will be set into the update packet after configuration of the route reflector. Once you implement the route reflector, then you will have a BGP these attributes, originator ID and cluster ID. If you're not going to add if you're not going to configure route reflector, this two attribute will be never seen. So let's do one thing. What I can do right now, I'm not going to advertise this route. I'm just going to remove from there. Okay, and start my route reflector. Neighbor 12.1 client, neighbor client, neighbor client. All the client has changed, right? Now let's do one thing. Debug IP BGP update. All they have a different route ID right now. All they have a different route ID. R1 has a 1.1.1, R2 has a 2.2.2.2, R3 has a 3.3.3.3, and R1 has a 1.1.1.1. Every router has a different route ID. Now understand this concept. Router BGP number 1 network. R1 will send the update packet to the router. Sending, right? Right. So if you see over there, when R1 is sending the update packet to the R2 12.1, that is this guy. Same update is happening as per the imagery. Do we have any information of the cluster and originality? No. But if you just have a look this Wireshark, this capture, the R2 and R4, I'm interested in the BGP right now. That 24.4, right? Sorry, 24.2, 24.2, that is sending the server is sending to the client, right? So now if you just open this packet and if you see the NRI same information is there, BGP attributes, we are having this information now. So the difference is happening in front of you guys. Normal BGP. So when the server is sending the packet, it is going to add the, when server is sending, server is 2.2, 2.2.2, 24.2, right? R2. R2 is my server, right? 24.2. Sending the information to client 24.4. And it's going to add the same information 1.0.0/8, right? And he's going to add the cluster ID, that's 2.2.2, that's a router ID of server, and originator ID is 101.1. Who is origin this route? Who is generated this route? So right now, if you see, and this both the size has a 32-bit number. Can you see the IP address format, IPv4 address format? So if you just have a look on our router number 2, it is able to receive the update right from neighbor, and it's going to send the update to this guy as well as R3 will receive this update right with the originator ID 101.1 and cluster ID 2.2.2. So R3 is able to install this update in my BGP table. All good. And if you just have a look, so IPBGP 1.0.0 is saying that, hey, this route is coming from whom? The next hop is 12.1 and advertising by whom? 23.2. And this is the originator ID is 101. The R1 is generating this route. R1 is generating this route. And this cluster is 2.2.2. That's my server. So server is reflecting this route to me. R4, if you see, R4 is able to receive the update, right? The same information, 101. And I'm going to install this update in my BGP table, right? Same information. Right now, every router has a different router ID. But let's do one thing. What I can do, I'm just going to put the same router ID now. It's the same, right? Same. This one is the 101. This one is the original ID 101 over there. Router ID. I'm going to make this guy same. Now try to understand. Just go to router number 1. I'm not going to advertise this route. Let's remove this guy right now. I'm just going to remove. And I'm just go back to the router number 4, right? And I'm saying that, hey, dude, do one thing. Change your router ID. Done. Neighborship has resynced, right? Sorry, reset. Now let's go back to the router number 1 and advertise the same person, right? What happened? R3 will accept this update, right? They will accept because the original ID is 101. And what R3 original ID is there? 3.3.3.3, right? But what about the R4? Deny this update because of the same originator. So when R2 is sending this update to the R4, when R2 when R1 sends the update to the R2, R2 will send this update to the R3. R3 said update is something like this 1.0.0. Original ID is 1.1.1. What's my original ID? 3.3.3. It's different, right? I can accept the update. But when R2 will send this update to the R4, what is the original ID? Mine is 1.1.1, and yours also sending 1.1.1. Let me discard this update. Let me discard this update. So in that case, R4 will never receive this update from the R1. So in the R4 routing table and BGP table, they will never update this information. Show IP BGP, show IP dot. I don't have the information of the 110 because of the this version. Previously, I was having, right, because previously what happened? They have a different because previously what happened? My router ID was 4.4.4, and I'm receiving from 101. 4.4.4 and 101 it's different. But after changing, it's not. You can do one thing if you want to accept this update. For example, if you have a look like this scenarios over there and you want to accept this update from R4 router on R4 router, you want to accept this update on R4 router, you can do one thing. Just go to router number 1 and say that BGP router ID will be, change the BGP router ID on R1. See if I'm going to change, what happened? Router ID will be changed. So now R4 can accept this update. Wait for some time. So R3 is receiving the update, the same update 1.0.0.0, with now the original ID will be 100.100.100. So if you go back to the router number 4, they can accept this update now. Because now R4 is saying that my original ID is what? My ID is 101.1. and you are sending with the 100 or 100 or 100, it's different, right? I can accept this update. Same way, if you know manipulate the cluster ID, that's actually not recommendation, right? If you know manipulate, you can. Cluster ID, okay, come on. I can tell me whatever cluster ID you want. I can make this as a 100, not 100 dot, you know, the 150.1. So the cluster ID now I'm receiving, previously it was the cluster 2.2.2.2 now. But this guys, I'm telling you this concept, the cluster ID concept, and if you go for the CCI examination, right, I will teach you this thing in a very detailed manner. We have a lots of classes on this thing, but just giving the overview how the thing is happening. So these two attributes will be there whenever you're going to implement the route reflector. So this is just extra information of the particular route, right? This is just extra information about the particular route. Extra information also means whenever the R1 will send this update, R2 will receive, and R2, the server, is going to add these two attributes. And these two attributes is used to prevent the loop in route reflector. So originator ID is going to use to prevent the loop within the same cluster, and cluster list is used to prevent the loop between the cluster. So hope you guys this thing is understand. If you have any question, you can ask me.